So today I am going to discuss about the Orgel diagram of D6 and D4 system. Okay, so when we consider the spectra of high-spin D6 octahedral complexes, consider the left part, consider high-spin D6 octahedral complexes. What will be the ground state term? It will be 5D. So this D6 has configuration of T2G4 Eg2, T2G4 Eg2. Then according to selection rule, transition of electron which is paired in T2G will take place. Okay. So it is clear that this transition is similar to D1. Now this 5D will be splits into, this 5D splits into 5 T2G and 5 Eg. Thus, there must be only one transition band observed. However, broadening of bands takes place. Consider the absorption band in FeH2O6 2+. It is usually found in between 10,000 to 11,000 cm^-1, and there will be broadening of the peak due to Young-Taylor distortion. Now consider D6 tetrahedral complex. Consider the right part of this board, and normally this Fe2 forms mini tetrahedral complex. Okay, and the ground state term will be 5D. And normally only single absorption band appears due to the transition from 5E to 5T2. 5E to 5T2. Transition FeCl4 2- is colorless because absorption takes place in near IR region. Okay. This much things you have to remember about D6 octahedral and tetrahedral system. Okay. So now let us consider D4 octahedral complex, the spectra of D4 octahedral complex. So when we consider the left part of the board, you can see the electronic configuration, that is T2G3 and Eg1. That is a configuration, and here the transition of Hall is actually taking place, and it is similar to D9 octahedral. So the splitting will be like 5E, 5T2, T2G, 5Eg, Eg will be the 5Eg, 5T2G. So when we considering the example of Cr2+, the absorption band for Cr2+ high spin is typically a broad band in region of 16,000 cm^-1, whereas another band at 10,000 cm^-1. This broadening takes place by Young-Taylor distortion. Here you can see three transitions. There are three bands. The bands 2 and 3 will be superimposed, and it will give broadening. And it is giving broadening. Okay. So in tetrahedral D4, split into E and T2. But the splitting is reverse of D4 high spin. Okay, D5 splits into 5T2 and 5E. So we can sum up, or we can combine all these systems, that is D1, D6, D4, D9 into a single diagram called an Orgel diagram. And it describes in a qualitative way the effect of electronic configuration with one electron more than a half filled level, one electron less than a full shell, and one electron less than half filled shell. Nothing that. Just remember this diagram. Okay. You can see in the last part, you can see the right side. It will be for D1, D6 octahedral and D4, D9 tetrahedral, and left part will be for D1, D6 tetrahedral and D4, D9 octahedral. Simply remember this. Okay. And also remember this broadening. yarn color distortion. All these things you have to remember. How many transitions? All these things you have to remember. In the next video, we will discuss about D2, D3, D7, D8 systems. Okay, I think all these things are clear now. And one more thing, if you have any comments or if you have any queries, please mail me at thekumikaworld@gmail.com. That's all. Have a nice day. Thank you.